All right, y'all ready? What is statistics? Anybody know what statistics is? Statistics is the gathering, calculating, and interpreting. Okay, y'all gonna listen or what? Y'all just gonna, okay. Now this is a Huberdism definition. Gathering, calculating, and interpreting numbers based on a subject. All right. Basically, let's say people that drive white cars on campus, or people that drive cars versus trucks on campus. All right. We go out, we lock the gates on the parking lot and count how many trucks versus how many cars. How do you know the difference between a truck and a car? A truck has a bed. Okay? Everything else is a car. Okay, that would be, and you're going out and gathering that knowledge, counting, calculating, and that's what we're going to talk about in the first unit, chapter 13, is what do you calculate? Calculate the two most important things in statistics. The mean and the standard deviation. Standard deviation. Now with the mean and standard deviation, you can find out a whole lot about the statistics that you have pulled in and calculated. Now, as we talk about mean and standard deviation, what do they look like? Well, with statistics, there's two groups that you're going to be working with. There is the population and the sample. How many of you have had probability and statistics in high school? Raise your hand high so I'll know. Okay, so maybe half the class, maybe 3/4 of the class. So most of you will probably get a little bit of refreshment from what I'm talking about. Population, we're talking about parameters. Parameters meaning Greek symbols. Now, why have I got to tell you if they're Greek symbols or not? Well, this is one of those things that in the real world, if you're in a meeting and you see a Greek symbol, you know it has to do with the population. If you see a regular symbol like an alphabet, like S or X, then you know it's a statistic which has to do with the sample. The parameter for, not parameter, it's statistic, not parameter. Now, statistic is a double meaning. I'm not saying statistic, plural. I'm saying singular, statistic, meaning that it is going to be an alphabet, a member of the alphabet, a variable. Alphabet. With the population, now I draw it backwards. It's not really written like that. It's really written like this. Okay? And that's called mu. And it means the average. All right? If you see, if you're in a meeting and the person is going over numbers and you see mu, then you know that is the average for the population. And we'll talk about what the population is in just a minute. If you see this guy, that's called sigma. That is equal to the standard deviation. Now the population is usually what the sample predicts for. Now why? Why do you not go out and survey everybody in the population? Because the population is the large what? It's the large group. And why don't you want to go out and survey the large group? Because it costs two things, and that is what? Two most important things in business.
Time and money.
Time and money. So what do? Just throw the population away? No. You use the sample to predict the population. Because chances are, if there's 5% of the people in this classroom that drive trucks, then chances are 5 to 8% of the population, which will be at Anderson campus, will drive trucks. All right? And there's other ways to go through. If you ever go through Math 120, there's, in the last 2 units, we talk about reliability of the numbers and how valid our parameters are and how valid our predictions are based on the numbers. We don't get into that in here. Statistic is the small group that predicts. Small group that we actually survey, and we take those numbers to do what? Predict. X bar is the average. And that's called X bar. That's what it's called, X bar. The average or the mean. S is the standard deviation. So if you're in a meeting in the future, next 5 or 6 years, and some dorky guy is giving these kind of numbers, and you see mu or you see sigma, then you know it's the population. If you see S or X, then you know it's the sample. And that's why you have to know this. Okay, it's not much. The formulas are the same, except when you see these, don't be ignorant and say that's the sample, because it's not, it's the population. It's just it's a thing to help you keep from being ignorant in a populated room. Okay? That's what it amounts to. Because the formulas are the same, and they mean the same thing, except one is bigger than the other. Okay? Now, there's 2 types of data in statistics. The first type is the type you're used to, and that is test scores. You know, test scores, you add up all your tests, you divide by the mean. Everybody in here has done that before. And I call that listed data. That's what I call it. And I'll give you an example. Test scores for last semester or this semester or whatever, and 85, 72, not 36. I didn't make a bad grade that bad. 92, 88, and what do we do to find the average? Add them up,
Divide by the
total, and divide by, take the total and divide by what? N, which is
how many numbers there are.
4, and that will give you your average. Now everybody's used to doing that. Now if I asked you to find standard deviation, you wouldn't have clues. Some of you would, some of you wouldn't, as far as how to calculate it by hand. Because I evaluated a teacher several years ago, and she was a night teacher, or she taught here at night. And she would put the problem on the board, and she'd say, okay, tell me the mean and standard deviation. And it was like the silent drill team. So with the calculators.
They're on fire.
I mean, she didn't even, so I asked her after the class, I said, just so I will know to put in my evaluation, did you go over how to find the mean and standard deviation. No, you don't have to. They just use a calculator. Okay. So she had me back.
Bank rate.
Hmm?
She made bank rate.
I mean, she,
She got the 32.
that is exactly why we got students now that can't make change at the cash register.
That's true.
Because they're not teaching how to think. They're teaching you how, they're programming students how to use a machine. And that's why. So, I'm going to show you how to find all this by hand. Not this. You'll know how to do this. I'm talking about the standard deviation. Now, what other type data is there? Well, it's a 25-cent word. Frequency distribution. Frequency distribution is a 25-cent word for a head count. That's all it is. All right, blondes, redheads, and brunettes in this classroom. Blondes, redheads, and brunettes. That's our classes. And over here is our head count. So, just looking over everybody. All right, I got 3 questionables right here. Okay, blonde, brunette, okay. So we got 2 blondes. Does anybody want to say they're a redhead?
Oh yeah, I can go ahead and say it.
And the rest of y'all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is a frequency distribution. Everybody knows how to use it, but did you know it's called a frequency distribution? A lot of people just call it a table, but it's called a frequency distribution. Now, if I asked you how to find the mean and standard deviation of frequency distribution, half of you would go, huh? You can do it on a calculator? And we're going to learn how to do that also. Because the 2 most important things to do, and I don't care if you can't add, subtract, multiply, or divide, you need to learn how to find the mean and the frequency distribution, not because anybody's going to ask you what the mean and frequency distribution is, but if you ever are given the mean and the standard deviation. If you're ever given the mean and standard deviation, that you actually know what the heck it is. Because there's a lot of people that take Math 120, and if I asked you what the mean is, if I say, give me the definition of the mean, 90% of you would go, oh, that's where you take all the numbers and divide it by the n. That's not the definition. Tell me the definition of the mean. Can anybody in here, I'd be willing to bet $5 on it. Can anybody in here tell me the definition of what the mean is? Anybody?
It's the average, it's something.
Isn't the average of the whole?
Yes, the average.
What?
I told you that. But what is that? What is the meaning of the word average?
Average is.
Don't even try it.
Yeah, I know.
Just tell us.
It is the number that is calculated that has no variation. In a group of data, if you want no variation, you've got to find that number. What is variation? This is variation. That's variation. This is variation. That's variation. All right? This may be the number of people, the age groups of the people in the classroom. This may be, this may represent 18 years old. This may be 19. This may be 20. This may be 25. This may be 28. And this may be 30. In other words, that's the only representations in the classroom. All right? And 18 years old, there's, let's say this is 5 right here. 18-year-olds, there's 6 in the classroom, or 7. And 19-year-olds, there's maybe 3. 20-year-olds, probably 8. 25 years old, 3. 28 what was that, 28 years old, maybe 1, and 30 years old, probably 10. So now we've got two things we can find. We can find N. N is always what makes up the classroom. And what is that? 10 plus 1, 11, 14, 22, 25. I have no earthly idea. 32. So 32 is N. But what else can you tell? Well, if we wanted to find the number right here that represents no variation. In other words, I could take this guy right here. Let's color him blue. Let's cut this guy off right here. Cut it off, and I'll put slants of blue here. And let's dump him right here. Okay? And let's take this guy, and we'll color him purple. And we'll put dots in him. And we'll cut him off and put him right here. And we'll take this guy right here, okay, and we'll put him, we'll fill this guy up. Let's say this is 2 right here. So we'll color it red, and we'll take 2 right here, and we'll put X's. And we'll put that right there. And then we have what? 7 left over? And let's just say that 7 falls right there. So what is the average? It's the number that you have. Where is the number that has no what? No variation. And that number would be this number right here. That number right there represents where the cutoff is to make everything what?
Equal.
Level, to make everything equal. That's what average is. And if you think about it, what do you do with your grades? You're finding the number that your test grades are basically what? Equal. Some of y'all have had Math 120. You've graduated from Math 120 or from 12 years of school, and you didn't know the definition of average. Why? Because that's not important. The only thing they want you to do is be able to what? Punch it on a calculator. That's what it is. It's the number that represents no variation. In other words, that line may be down here below 4. It may be way up here. You don't know where it is. But when you find the average, you're finding the number that represents no variation. Okay? So that's your definition of average. Now, why is that important? Because basically it's finding a balancing point in the data. If I'm taking these these are in excess of the mean line, right? I'm cutting these off, I'm putting them here, 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 part of this one here, and the other part down here. I'm finding the number where everything is like you said. Somebody said a while ago, level. Why is that number so important to you? Let's say these are your test scores, or you're finding the average of your test scores. Why do you want to find the average? Why don't you just take the highest one?
It would account for all the other grades.
Doesn't account. In other words, the best measure of data is to find where everything levels off. Because you could have a 52 in there, you could have 107 in there. If you go with the highest number is 107. This says you're a genius. But that could have been a test on how to color a coloring book versus the test that you made a 52 on, which was how to get a job in the real world. You see what I'm saying? So you don't want to take the highest grade or the lowest grade. You want to take a sample of the whole thing, and that's what average does. Now, the only problem with that is you do that with this, no problem. What about this? A little bit of a difference, isn't it? For one, is this qualitative data or quantitative data? It's qualitative. Write that down. What is qualitative data? What? Non-number. How many students in here have blue eyes, green eyes, or brown eyes? That's qualitative data. How many students in here drink water versus Cokes or Pepsis? That's qualitative data. What's quantitative? Age, height, weight. That's qualitative data. So, quantitative. So there's two types of data. There's qualitative, which means non-numbers, and then there's quantitative. Most of the time, our data is going to be what? Quantitative.
I say number 5.
Say again? Numbers. Yeah, just leave whenever you want to. Come in whenever you want to. That's fine. Now, there's two other things that we need to talk about. We've talked about what types of data there is. We've talked about what types of data you can actually survey. And now let's talk about two sets of data that are very confusing to some people. And that is discrete and continuous. Now I have a very special way of showing y'all the difference between discrete and continuous data. And it goes back to your elementary school days of rational and irrational. So those of you that have a calculator or a calculator app on your phone, go ahead and get it out. I don't want everybody to get it out because we're going to use it today. And I'm going to ask you to type in 3 things or 5 things for discrete and irrational. I'm going to ask you to type in square root of 49. I'm going to ask you to type in 1 over 3. I'm going to ask you to type in 2/3. And I'm going to ask you to type in, that's 3, not 4, Dort. 3 and 4. I'm going to ask you to type in 10 over 2. Okay, it shouldn't be that hard. What is square root of 49? 7. Now it's positive or negative 7, but for instructional purposes, we're just going to say 7. 1/3 is point what? 3 what? Repeating. I put a line over that 3 because it keeps on going. 2/3 is what? 0.66, and it keeps what? And what's 10 over 2? What can you tell me that all of these numbers have in common? One thing that all of them have in common. Well, you can't say it's decimals because 2 of them aren't decimals. You can't say it's whole numbers because 2 of them are whole numbers. So you can't take fractions, decimals, or whole numbers. That's out the window. They're not prime. You could say what 0.333 is because 3 is a prime number. So that knocks that out. So not prime, nothing like that. It's nothing mathematical, okay? I want you to look at the numbers and tell me what all of them have in common. You can't say repeating because these two aren't repeating. Let me ask you a question. If I wanted to write this like this, is that a problem? Or this one like this? Okay. Now you can say they're all decimals, but that's not the answer. Okay? Has nothing to do with math as far as addition, subtraction, multiplication, division, numbers, or anything like that. It has to do with what you're looking at. Shelley, pick on you. What's this next number?
I don't know.
Yeah, you do. What's that next number?
They'll never change. Is that it?
They're very what? Like men. They're like men. What are they?
Predictable.
Predictable. You can predict these two things right here. All right, get your calculators out. And I want you to tell me all the numbers. Now go slow because I can't write as fast as y'all can talk, especially some of y'all.
No, it's square root.
All right, square root of 7, or raise 7 to the 0.5 power. 0.5 is square root. If you raise something to a 0.5 power, that's the square root. So what is the square root of 7? Give me all 10 digits if you got it.
2.645751311.
She ignored everything I said. I'm not what you call punchy. I'm just slow. It's just the way I talk. Who says that? Rocky. Good job. Got some movie buffs in here. All right. 2.645 what?
7513111.
All right. Give me $100. I'll give you $100 if you can tell me what that next number is going to be.
1.
No. Actually, it's like 4 or 5, I think. But why can't you predict it?
Because
There's no what?
it's no pattern.
There's no pattern. It just goes on and on and on. There is no prediction. There is no pattern to this number. That's why I picked it. How about square root of 2?
1.4114213560.
Okay, tell me what that next number is. You don't have a clue. And pi, 3.14153993. Uh-huh.
Yeah, you're right.
39 or 93? I transpose the 3 and the 9 sometimes. What is it? Just hit pi and enter.
3.141592654.
26. There and 3 in there. Okay, tell me that next digit. Maybe that next digit is 3.
4.
Now I could show you how to calculate those digits, but it takes about a page to calculate each one. You can't tell me what the next number is. Not predictable. Now, if something is predictable, it's pretty much substantial, right? Substantial. Meaning that you can put money on it, right? That you know that that number exists and that it's located on the number line, and without a doubt you can locate it, and that's it. These you can't do that. You can't locate it because what? You don't know what that next number is. You can't locate it on a number line. Technically on a number line, this is what's happening with those 3 numbers. This is, let's say this is 3, and this is 4. Now you got to think out of the box. Say Shelley leaves when I say think out of the box. All right? Uh-oh, something's wrong. All right, 3.14. Now you got to say, okay, this is 3.1 right here. Let's say this is,
Can you mark
let's see, this is 3.5. That's 3.2. All right? So 3.1 is where? Right about here. But basically, you can't say 3.14 because it's 3.14 what? 5. Then what?
9.
9.
2.
That's 900s. That's back this way.
2.
Then 2. You got to go back this way. Then it's just going what? Back and forth, back and forth. You can't tie it down. Sorry. You can't tie it down. You can't say, that point is right here and I'll bet $100 on it. You can't do it. And you can't do that with irrational numbers or continuous numbers. Well, what does that have to do with statistics? All right. Everybody take a look out the window. All right, everybody see that little sign down there at the sewer pump station?
Yeah.
All right, the little sign is green, it's got a white back to it. Can't see what it says, but it says this is a sewer pump. Please stay away from it. All right?
I know, but
It's called a pump lift station, is what it's called.
I believe.
It sends sewage to the sewage treatment plant. All right. Let's say that I have a box of measuring utensils here. Measuring utensils, what you talking about? Well, let me pull up. Because some of you have never seen these things, because half of you don't know how to read a ruler anyway, but some of you don't know what I'm talking about. Watch him pull up a bunch of EDMs. Measurement, measuring tools. Okay, what is that? It's a ruler. Okay, that's a ruler. What is this? Tape measure. Trying to find, what's this? A tape measure, it's a cloth tape measure. This is a steel tape measure. What is that? That's what I'm looking for.
You never seen one of those? Contractors use those.
It's called a carpenter's measure. Before they had the metal pull things, that's what carpenters used.
My granddad used to use one.
My granddad had 2 or 3 of them. And he would keep them in his overalls right down here. And whenever he needed to measure something, he just pulled it out and measured. Everything okay? I thought you got a phone call or something.
I'm good.
Hmm?
I'm good.
Okay. I thought something happened in school or something. Just trying to be caring. Just trying to be caring.
Your turn to go now.
What is going on? I must be making y'all mad or something. All right, this is what is this? That's a measuring wheel. You wouldn't use that because that measures distance, linear.